Just ran our PCR on the gel. It's been about 12 minutes, and you can see that we have these two blue bands, which it's probably going to be easier if I hold my hand to see. So there's a light blue and a dark blue, and that tells us that this thing has run well, and we're now ready to take a picture of it and cut out our bands. That means we're gonna get the right size of DNA that we want, that we've predicted, and then we can purify it in order to play with it later. So I'm holding this gel in my left hand already, but the first thing you want to do is, assuming you have clean gloves, I have clean gloves, these haven't touched anything, I'm going to take my right hand, I'm just going to put it behind me. I'm only using my left hand for right now, and that's because I want to keep this free and clean of imethylene bromide. So while my my right hand is behind me, my left hand is contaminated. So I'm going to bring this on over to the imaging box. I'm going to place my gel on the UV. I'm going to close this. I'm all using my left hand. I'm going to turn out the light. Now with my right hand, which is clean, has not touched any ethidium bromide, I can use this mouth. And you see it says no gloves, no gloves. That's because, you know, when gloves are contaminated by ethidium bromide, that's bad. But I've been extra careful to not touch any ethidium bromide. So I'm going to snap a photo. I'm going to turn down that exposure. So I'm going to do a couple exposures. That's one exposure. Decrease the shutter speed. And turn that off. I don't want to leave the UV on my gel for too long because it'll be constantly irradiating my DNA and causing a lot of mutations, which is no good. Double click, and you can see that all of these PCRs worked. I expected a band of about 6 kb, and that is, let's see, 2, 3, 4, 5, 6. Yeah, that's about right. And these ones failed. So if you remember from the last video, we loaded, each sample got 2 wells because the full sample did not fit in 1 well, so we had to do 2 wells. So we have sample 1 is here, sample 2 is those 2 lanes, sample 3 is those 2 lanes, and sample 4 is those 2 lanes. So now that we know what the gel looks like, we can decide what we want to cut. So we know we want to cut those bands. If there had been multiple bands, then we want to cut out only the correct band. So in order to cut it out, we throw it on a plate, the top of a plate, and we come over here. Now that I've touched the computer, I don't care if this hand gets contaminated, so I can touch the bromide and it'll be fine. So in order to cut it out, I'm going to get to the UV box. I'm going to turn that to 302, and I'm going to press on. Now whenever I'm cutting, I always want to make sure that this face shield is in between my eyes and that UV light. Otherwise, I irradiate my eyes. So when I put my gel down, you're going to see that it lights up. I don't know if you can see that in the camera there. And it looks very similar to that image we just took. I'm going to cut out the bands that are right there. So I'm going to go ahead and do that right now. So my cutting technique is I just make a slice along the top, slice along the bottom. This is not the best slicing I've ever done. And then I'm just going to slice sideways, and since these are side by side, I'm going to be slicing them out as 2s, and then they're all sliced up. I'm going to hold them up, push them down, and I want to keep these all in order. And you can see that I have a bunch of extra gel crud along the bottom. I want to get rid of that, so I'm going to try to do that right now. So by slicing right there, you can kind of get rid of the majority of that excess gel. That's 1. That's 2. That's 3. So now we've kind of shaved it down. You see if I can kind of turn it around. There's still a little bit of excess gel gunk there, but we've gotten rid of the majority. And all of our gel fragments are in order, so 1, 2, 3. And there's the top of our gel so we can remember our orientation. So now I pull this out. Oh, I want to turn off the UV. Always remember to turn it off. And also, if it's hard to see, you can put down our little shield here, and it makes it even darker so you can get a better exposure. And we're going to come over here, and now I want to get our fragments, and we actually want to purify it. So these fragments have our DNA in it, and we want to go from this gel fragment that had a bright orange band on it from that picture. We want to go from that little gel fragment to just some liquid with some DNA in it. So how I'm going to do that is I'm going to take off my glove, and I've marked a bunch of tubes, or 4 tubes, with the appropriate numbers, and I put a pipette tip in them. And unfortunately only 3 of my PCRs worked, so I'm going to be picking up clones number 2. So I pick up a tip, grab that fragment, which is fragment 2, and just kind of stick it on in. Get clone number 3, stick it on in, and grab number 4, same deal. And then normally we'd clean this up, I'll do that later, but we're going to just move on to the next step, which is going to be at my bench, and we need to get the DNA out of here. So those gloves are contaminated by sodium bromide, so I'm going to throw in some new clean gloves. And in order to get the DNA out of that gel, we need to melt that gel and then do a zymo gel purification, which is very similar to a PCR cleanup, except that it's been designed to melt the gel. And then once that melted gel, it's a mixture of melted agarose and DNA. Once it's all melted and good, we can run it over a column and rinse it, wash it off, and then finally elute it. So for my P1000, which appears to have gone missing, steal somebody else's. We're going to be using 700 microliters of ADB. Again, I'm still running low on ADB. Hopefully we can get through this one. Oh boy. So 700 microliters. Pull it out slowly. Check that the volume looks good. It does. Checked. Liquid. Inject it into the tube. And the same thing for the last one, we put it in here. Now normally what I would do is I would just cap this and then go and melt it, but since the fragments that I put in there are particularly large, I'm going to try to speed it up a little bit by grinding it. I'm going to use the tube as kind of a mortar and pestle. So this tip hasn't touched anything other than the buffer, so I'm going to, I don't know if you can see that, but I'm kind of jamming my DNA or my gel fragment down in there, and I'm trying to kind of break it up a little bit. I want to try to increase the surface area so that more buffer can access it and melt it quicker. There we go. Kind of mushed it up a little bit. Then just kind of eject that, cap it, and I'm going to repeat the same thing for the other 2 samples. Close up my ADB. The same thing. You can see that gel fragment. I'm just kind of jamming my pipette tip. You can see it's breaking up a little bit now. We also want to be sure not to overflow your tube. Eject. Get rid of that tip. And last one. And we're going to break up that final one. That one doesn't want to break up. Okay, well that should be fine. Okay, so now we're going to melt it down. In order to melt it, we're going to take our samples over to the heat block, and they're going to stay at 55 degrees for about 10 minutes. You can come every now and again and shake them up. That will help with the melting. So we want to put a little bit of water, 1, 2, 3 samples, and then we just tap them down and drop our samples in there and just wait a little while. Again, 10 to 15 minutes. Maybe after 5 or 10 minutes I'll come back, I'll take a look at them, I'll shake them up, and that will help speed it up and get the gel to melt a little bit better. So we'll be back after these have finished melting, and we're going to finish up the gel purification.